Alright viewers, now we continue where we left off from part 1, or episode 4. Episode 4, the reason I split into part is I need to regain my focus. And here I am, I'm back to this again. Now, we're going to cover some of the mass thing. 10 sign costs. So this is the fable. Now, the bigger confusion, as I mentioned before, is, and I'll show you here, 45. This is bigger confusion. Because if I go to my city, the calculator, and 10, 45, 45, 10, 1. So, white? Is this how it works? 45, 10? The 10 and 45? Okay, white? So, is it 10, 45? White? But sadly, no. But sadly, that is not the case. No. But, and that is why the confusion is there, and the confusion is in form of larger error. But it's actually in weightings. But there's a way we can work around. We have to use math to weightings, and we'll put 45. But if we do that, now we get 1. Whoopee woo! We got the value of 1. Now, the way to clear this confusion is we use pi. Okay, math.pi is equal to 180 degrees. So, I already got all this. And so I got B and C. And it worked out nicely. Now there is a bit inaccurate, sadly. Now for D, I want to convert the degree, so I use math arc10. So I use A10 too, a bit confusing, but we go for the difference in Y and then the difference in X. Work out to be 14 degrees, and then I just prove it is right by do math dot 10 at 14 degrees, and it worked out to be pretty much the same answer, near 0.25. And as you see in my output, I have proven it. Alright, now I'm going to cut this off. So, to save time, and we'll move on to the next part. Now, the next part I'm going to prove is actually, now, for the 10, which I get to that point. Next part is I'm going to cover is Pythagoras' team. Now, Pythagoras' team, and I give you this: the sum of adjacent square and the opposite square is equal to hypotenuse square. So for that reason, we are going to prove it. So, we're going to prove it this. I want to prove it, so I'm going to enter any weightings I want for 0 to 90, by the way. Make sure I get it right. And I'm going to enter 1 for my sample. And I get the double. Now, whatever weightings I enter, that can convert the double. And then my F. Then, what I do with that F is, see, I get the mass, the cos of that F, raised to that to the power 2, that 1. I do the same thing for sine, I then add them both, so I add 2 square. The cos will come from the adjacents, I square that adjacent. This is the opposite, I square the opposite. And overall, this should be 1. So cos square A plus sine square A is equal to 1. prove it. I'm gonna enter 1.2. And there you go. We got the answer 1. And it had proven Pythagoras' team is a success. Now remember, to understand this part of code is, remember they're bird maths. Remember we have a power, and this is terminology. Working the bird maths first of all. So it works the cos of s first. And then, where is this use power? Is it to the power 2. That's how it works. Now, the next thing is I'm going to use e-cos. Now, there is a pitfall to this. Because I'm going to integrate it. Okay, and this is the cos. Yeah, and I think it go around in line of cast. Cos or sine. And so I'm gonna try it into 2. And that should be 2. And into 2 again. See, 2 is incorrect for unknown reason. But yeah, it may have more than one value. Because if I get the sign of 2, I think, yeah, it can get a value. You know, whatever it is. But yeah, they're actually a -1. Yeah, for unknown reason. Yeah, I think, or CAS. Yeah, that's the sign, because if I get 2, yeah, this is due to explanation of cast when it comes to getting the sign. So just say it does work. Just say 1.1 for the sake of argument, okay? Just for the sake of argument. There you go. Okay, for the sake of argument, we're going to stick with 1, okay? But what I'm trying to prove it is, when I get the cos of that radiance, okay? I get the cos of that radiance, and it will give me an answer to that. And then I get the arc cos. You know, normally you get the arc cos of that answer, and you get back into the radiance. You know, like arctan. If you get arctan where the answer is 1, arctan 1 is 45 degrees. Or pi over 4. Remember, tan 45 is equal to 1. But if you get arctan 1, you probably get it back to 45. This is what I did here. Basically, how the arc is basically how it works. It's pretty much getting the radiance of from the answer radiance that gives you the answer. That's how arctan, and it does prove pretty nicely. Now next we're going to prove tan A is actually sin A divided by cos A. Now I already done this. I done this for 60 degrees and 120, and long before it worked. Now the next thing, alright, I want to close this out here. Save time here. Alright. And move on to this. Now, here we're going to convert this. Now, there's a confusion. If you really want to put the angle, so here at 90 degrees, I use mass to the radians. It taking the degree, convert the radians. Therefore, I can get the tan of that radians that I intended to. And lo and behold. And another thing is, now, normally in calculator, let me see now. So, where my calculator, yeah, which I really X out. So, why? I get 1090. That's invalid input, so it's undefined. But what about this? And yet again we get this, and we get this answer. It's because of the pi inaccurate. God, it's the pi inaccurate. That's really annoying. Sometimes it can be annoying with this stuff. We actually get this answer, and long before that is not right. Surely, should we get? Yeah, sure. Are we supposed to get this? And we're supposed to get this, a Whitney exception. But no, we're supposed to get this, something like that. But no, we don't. Next, I did the same thing for the sign. Okay, now I do the same thing for the sine 60, which should be 0.833. It's actually the 5/6. Okay, it's the 5/6. Now I don't know how to prove that, but I'm not gonna prove it. Okay, I'm not gonna prove it. So if we get the 5/6, and I'm going to explain through it. Now here we can use a format, string.out format. Now we input this string is position followed by what index you want, what the position argument. This is the first argument, which is the upper. You put a dot and state your position is close to 3 decimal place, 3f. And then you put /n for next line. And I actually do them again to prove it. String.format and put your special string and position 1 first argument point close to 5 position place. And only hope you got it. You can use decimal format, df, new decimal format, and put your special string and state how many position you want by hash. You put a df, then your format, and you format wherever you want to format, which is upper, which should be this, and it gives you this answer. And there you go. Let's drop by a couple back here and just prove it. There you go. Case closed. Alright, now next is mistaken bitwise. We're doing okay, 30 minutes. Do we need to do that? Yes, we do actually. I go through quickly, and this is just basically increase, decrease. Then my power meter is 150, and I take in the scanner, and we take a system.in. Then my string, and this is my button. This is a string away. Remember, a string is an object, and I'm going to use a for loop. I explain for loop in a second. What basically what that means is I want this to loop 5 times. Okay, 5 times. Attribute I. Remember the condition I told. Remember the condition I told, and the sign and rational operator is actually greater or equal to 5. I want the one 5 times, so it'll be 1, 2, 3, 4. When it hit 5, this is true. I want to run this again. 5 is true. Once it hits 6, no, can't want that. So 1, 2, 3, 4, 5. That's the way I want. So I give them an int choice. Now this, and I use short message dialog. Now first one, first argument, I just know. I put 2 string. The first one is text, and this is the title. Now use the for option, J option, information message, no button, and button 0. I highly recommend you remember that the for option and information message. Maybe confusing, but try to remember that. Okay, I like if I remember that. Now, and then once you get the choice, and then you go through the if statement based on that choice. So if the choice is equal to 0, then I state I'm decreasing, and then I be asked, first of all, now this is a warning. I'm gonna tell you something like this. This is the bad line, okay? Because this is a bad line. I'm gonna tell you one thing. This is hard to understand. What's that line? What's that? So I don't understand this. What that's gonna return? I don't know. And then I just partition. This is confused. You see, this is confusing. Absolute confusion. But I tell you what. I entered this. That will return an int, and then that will return a string. And at the partition, assume it's an int. And I get power output, and I subtract that int. That's confusing. Like, it would be easier to do this. It'd be a lot easier to do. Did I put this text? No, what mistake I give out? Yeah, I shouldn't get a mistake like that. Oh, come on. Oh, shoot, man. Sure, it shouldn't have happened. And I get another larger error because should not be a larger error. Oh man, I have to stop the failure. Okay, I'm back again, and I have to stop the failure. Yeah, I'm knowing it's larger error again. Text. I should declare before for loop. What annoying error there. But it would be better if you do this instead. Text equal to this, and input my number that would return a text. It's a string. And then I convert that to int. So much easier. Now, if the choice equal to 1, you just enter this. You pretty much do the same thing, but increment this time. Let's give it a try. So we'll go decrease and do 22. Decrease again, do 44. Decrease one more time, 30. See, now increase again, and do 100. I'm breaking the rule. Right, there you go. Thanks for taking part. Now, alternatively, you can do. So you can do the switch. So we're going to do that. Oh, I better undo that. Yeah, I made a slip here. That shouldn't have happened. Okay. It should be that. That would be BS, man. Absolute BS. Now, I can do a switch. So the switch should be choice. If remember, the choice is an int choice, and a J operator pane. Do you want to increase? Now that would be a 0, and that would be 1. There is 0, and there you 1. Now -1 means I press X and just break from that. So let's give it a try. Should be the same results. Oh no, that shouldn't have happened. That should not happen. I'm sorry, I must have slipped. Oh. And there you go. And then after that, I get, and thanks for taking part. Alright, now let's go the test bitwise. Then my test number 1055. So let's test the number out. Now, so I'm going to test the number, say 64, okay? So we should have one. So let's test this number 64. Now we should get 1 0 0 0 0. There you go. This should be the number. And when you're in for all that, it should be 1 1 0 1 1 1 1 1 1 1 0 1 1 1 1 1. So I get, yeah, should get 8. Yeah, that should be a 13. So 13 by 16, 16 by 13, 160, 208 plus 15 should be 223. Alright, that should be a 223. Let's see, can you get one right? Then my 64 is passages and print them out. Should be 191, and I was wrong, man. Yeah, I was horribly wrong there. Which I shouldn't be, because no, I was wrong because I mean, see, maybe said that I should not, and that's cost me. So I'm gonna start this again because I got it wrong again, and now I'm gonna have to do it 100. Yeah, I got it wrong. That is a shoot mess up. I mess up the figure. I should never mess up. So 32. Now there's a 96. So I tell you what, that should be the answer. 1 1 is a 96. And surely there's a 16. Watch out. 96, and then it should be 4. Okay? Then you convert that and see, now this isn't that, this is the bitwise complement. Now you aim for, and that is the bit. Aim for that. So you aim for that. Now we should get the answer here. That would be 9. 9 by 16 is 144. Now that is a 13, 13 and 157. Alright, let's see, can I get it right this time? No, 155. Man! 144, and man, I didn't get that one right. That's made to be 11. Wow! Okay, 3 times. Let's try for the 3rd time. And please, can I once get it right? Man, this didn't happen. Right, got 96 and 112. That'd be a 7. God, really annoyed about that. I'm really annoyed. And that should be 6. Okay, now invert that. 1001. God. Right, should be a lot easier this time. Man, and there should be a 128, 127. Why, can you get it right this time? Thank you! Third time! Success! And as you see, actually it is right. I just carried the one incorrectly, especially the last one. Man, especially the last one, 44 plus 13. It's actually plus 11. All I have to do is know the bits right, because that's the thing about it. That is another thing. Knowing the bits. As I mentioned before, you have to know the bits. You see how bad, and that is how that. You see what they sample now. If you're doing my job and I get the bits wrong twice, that can hold back the job. I do not. You want to know the bits. I really got hammered on that one. That was bad. Right, and here you see 118. How this works is you wanted this statement, and then I can set in that out. Now I get the bit right. It's actually work out the minus. It go for the minus figure too because of the sign, like sign. So that way I put 256 plus, and that gives you 137. You do the same thing if you go greater than the 256 or equal to that, but less than that. You just up it. You go 65536 and do the same thing. And then I got 137. Now, that's the test number. The test number is 118 actually. So let's keep it that way. Now 118 should be 236. Now 118 should be 5472. Now here we're going to take another test number 501. Now this is an odd number and we'll go 1. Its the answer going to be 250. It dropped to 0.5. It dropped to 0.5. It does not round the number up. So get that straight. Now, if we get 2 here, with 250, we actually still get 125. So I just drop it. Now this one is a sign shift operator. Now we're going to prove it this. So I'm going to run this one more time. 250. Now if we work this out. Now be careful here because this one. Now test number. Now if I shift it right first 1 and shift it back left 1. And this is where it gets confusing. You would drop the decimal place, and when you shift back, you can't revert it. Therefore, you get the answer 500. But if you shift left first and then right, you get 501. Now they're not the same. And that thing. So therefore, don't assume. So when you come to this two, do not assume they're the same. They are not. They're not the same, so might be best to shift. So remember, they're not the same. So if other one is shifting right first and then shift left, be sure you shift right. Now we're going to have. Alright. Now here we're going to have this. This is bit right hand. So 53, 5B 101. Okay. So 101 and 11. And the answer should be, and this is and that both must be 1. Now there's 0, 0, the one, only one match, so the answer is 1. 12 and 11. None of them match. So the answer is 0. 9, you get 1, 1, 0 and 1, 1. So anyway, the answer is 1. I know that. Now, next one is XOR, or you get 1, 1, 1 and 0, 1, 1. Now the answer is still actually, yeah, answer is not 1 actually. I'm sorry, but it's not. It's actually 6. So only one is 1. So this is good. This one isn't. So 6. Now the answer is 15. And 1, 1. And it is 15. The answer is 10. One is, that's 0. That is a 1, 1, 8 plus 2 is 10. Now or is you just, it's pretty simple, 7. Okay, here's another one, 1, 1 and 1, 0, 0. If one or more is 1, you can put 15. No, this is different. Okay, now it's 1 this time. 1, 0, 1, 11. And there you go. And it is. And it is foolproof, viewers. Now, this is 3-way OR. Okay. And I'm gonna prove this. 101, 11, 11. This way it could be odd number out. If the odd number of 1 is 1. Now, so this is gonna be 1, 0, 1, 5. Now, this is a shortcut here. This is a shortcut. 1, 1, 0. Should be 6. Now, this is OR 5 or 3 or 3. Okay? 0, 11, 0, 11, and a 7. Okay? And that's how it works. Now, we're not done yet. We'll go on to more math stuff and doing good. Alright, now we get to the action. Now we're going to get to max and min. So this is my array of int. It's 2047144759, and I'm gonna read this. We're gonna read through this. Just say we're going to do this way. Alright, now this is a quick way. Now the max is 2, the min is 2. Okay. Now we're going to give it int equal. The int will be x equals 0. That means start at 0. Now remember, this is 0 index. Then why that x is less than a dot length, less than a dot length, because the length of this is 9. But because we're dealing with index, a dot length. But for more conventional way, like, would be better if we just say a dot length minus 1. But just say for now, we're just reading through this, and we'll start with this, and then we'll just put a nice simple one. If ax, so wherever that will come, and the max and min is set to 2. So if this is greater than max, then make max become this. Likewise for min, and then so on. You print them out, and once you do all that, cut a long story short, the max is D9 and the min is D0. So there you go. Right. Now there is even a quicker way here. So bear 1 minute for one. So there is a quick way and a dangerous way. And here the for loop. Yeah, for a equals 0, and there you. And this is your int. Okay, first of all, this you declare how the starting point, and then this you count. This is the condition, and that's your counter. Okay. Now I do not increment this. I just have to put this in. Okay, and then the max is equal to max dot max. What? How did that work? Now this is confusing. I put max equal to 2. Okay, guys? And then I put this in and keep reading. Now, first of all, I get x. Remember, inside the bracket first, and x, you get the number up here, okay? And whatever the number I get. And then, what is that max is compare with the max I got. The max is 2. Is compare those two. And what does that max is get the greater of those and get that answer put in. I get max. Same thing for the minimum. If I get mid, get the one that is less than mid. So now, if you get 0, 2, 2, 3, 2, 2, 3, you get to 3. That max can change. And you feed into that figure. And then loop it again. This one had changed. And so on. It's a quick way. It's hard to understand, but it's a quick way. Alright. But it works. Alright, next is the log. System that are print in max. Skip that. Alright, now we're going to get system.log 1000. So here we go. And this is your answer. This one will say 6.9. This one say 3. Now, log is actually log the base of e, which is 6.9 basically. Log the base of 10 is 3. Now 1p, I really don't know about that. Now here we're going to figure out how much of base number 7 could be raised to get this number 16,807. So what we're saying is we're going to say log base is 7 or 16,807, and I'm going to prove it. I already did the calculator, and if I see, I keep Xing that calculator. We want to prove in this. That's the answer we want, okay? So I know it's 5, and I expect it to be 5. Okay? Expect to be 5. So what we do is so you get it, use 2 double, you get the log of 7, and you get the log of the base number, okay? What you're trying to get the log of the base number, get the log of the number that will start you the target results. Okay, there you go. And there you go is, and so you work out this and this. Then you get A2. Those are 2 numbers we got, 1.9 and 9.7. Then I get sitting dot point in. Now this is large and this is a tricky part, and I'm trying to prove it. And as you see, 5 is the answer. Now sitting dot printing, and I'm going to prove it this is right. The log of the big number I'm trying to get, and the log of that base, and this is the base number I'm trying to get log of base. So I divide that, so I get this and divide this, and it should be 5. And lo and behold, it is 5, almost. But of course, because we don't like all this larger error. So what we're going to do is, what we're going to do about it? Now, then we get, yeah. Then you get this. Just close to 4 position place, you get 5. Now, next one is random. Now, finally, before we end the episode, lasting nice time. I expect it to be a long video, and we're going to get it finished. Now, next part is random. So we get system dot output in mass dot random multiply by 10. Now, I intend to choose a number from 0 to 10, but I intend to want to do it not 10. Okay? 0 to 10. It's actually 0. Well, yeah, 0 to 10. So normally, how did this math that random work? It choose randomly a double number from 0 to 1. And what I'm doing right here is wherever I get a, I multiply that by 10. Now, why is 10 to be exclusive? But that's it. Now, next, but the most simple way to do all this is what we do. Now, this is how it works. Actually, I'm going to do the bad one first. This is how it works. Now, you put a bracket in a while. And I think I messed that. Did I mess it up? No, I didn't actually. It's math.random. Multiply by 10. I want to get 1 to 10 exclusives. 1 to 10. So I get math.random first. Then I multiply by 10. Okay, so whatever I get some nice figure. Then I add 1. So it makes sure if it happen to be like 10.991 like that, it's 10, okay? Just add 1 for sake of argument. Because remember, it's 0 to 1 originally. So yeah, that should work. Okay, 0 to 1, okay? And then you get, if you happen to get 1, it might be 0.22, it'd be 1.22, you know. And naturally it is. Is it? Yeah, that's good, that's good. So there'll be 10 possible number, and it should start with 1, just add in 1, okay? Now once you've done all that, you put it in, and that get rid of all the ones that all the figure after decimal. It just chop off the decimal. No rounding up anything. Use the int. Do not use the round. Now, and lastly, before we end, I will show you one incorrect way to do so. Now, if you math.random and you put bracket, and remember it's always 0 to 1, you're gonna get, and then if you use that and you put int, so it's just right here. If you just use int like that, it's gonna be 0, and then it's 0, and that is a larger error. So that's it. You do math.random multiply by 10. Okay, add 1 that will give you, and chop out all the figure. Int, it work. Alright, viewer, that's all for this video. I did the best I can. I made the. It was tough to make it, but I did it. I see you in episode 5, where we will do more on for loop and all the loop. I'm going to take a nice break from this, and I hope you enjoyed the episode. If you like this episode and you are entertained and you're motivated, well, you know what to do. Well, please wait, subscribe, and come on, my failure. And this is Gryff-User signing off. See you next time.